Hello everyone, and thank you for joining me. Now, picking up where we left off, we've applied a very basic redistribution configuration. And what that means is all we've done is we've taken the EIGRP learned routes on these links and redistributed them into OSPF version 3's routing domain. And we've taken the OSPF version 3 learned routes and we've placed them into the EIGRP routing domain. All right. Now, this is a very peculiar state because the EIGRP topology table in this routing domain and the OSPF database tables in area 0 and area 1 have been flooded with prefixes that they may never use. Or, as I mentioned in at the beginning of this video playlist, that area 1 and the EIGRP autonomous system routing domain share the exact same IP version 6 subnetting, which can be dangerous when you're doing redistribution. All right, you could cause some inconsistencies in your routing. Now, what I'd like to do is I'd like to clean this up a little bit. All right, I'd like to clean it up. So to do that, what I would like to do is focus on Acme Core 2. Because on Acme Core 2, what I want to do is I want to redistribute into the OSPF version 3 area 0 backbone only the IP version 4 and IP version 6 prefixes that are attached at the access layer on router 3, which is EIGRP router 10, okay, in this particular circumstance. Now, the other thing I'd like to do is I would like to take the access layer IP version 4 and IP version 6 prefixes that are currently being regenerated by this autonomous system border router as an LSA type 3, I would like to have these prefixes redistributed into EIGRP in addition to the default route that's also being originated by the ASBR in this core. All right. Now, once we've done that, I'd like to go take a look and see if we have end-to-end connectivity. So having done that, let's take a look at my configuration. So what I'm going to do is we're going to go on Acme Core 2, and we're going to use a prefix list. This is an IP v4 prefix list that's named into OSPF. So what do we want into OSPF version 4? We want the 188.24.64.0. So we want to advertise into this domain this prefix, which is essentially the access layer attached to router 10. At an IP version 6 level, right, we would like to have the IP version 6 equivalent also being redistributed into the OSPF version 3 backbone 0 area. All right. Now what we've done is we've used a route map and we've named the route map into OSPF version 3. Okay. And with a sequence number of 10. And we've said, please match the IP version 4 prefix list version 4 and set the metric to 20. Do the same thing for the IP version 6 prefix list, v6, and set the metric to 20. And then we've applied the route map under the appropriate address family in the OSPF version 3 process. Okay, so this accomplishes the task of obtaining the IP version 4 and IP version 6 prefixes in the access layer and having only these prefixes redistributed into the OSPF routing domain. Now, moving forward, we have to do the inverse, because what we do want to have is we want to have the default route enter into the the EIGRP routing domain. We also would like to have the access layer IP version 4 and IP version 6 prefixes that are attached to router 7 enter into the EIGRP routing domain as well. And we've done it also for the IP version 6 equivalent. We follow the same process. We create another route map, but this time it's into EIGRP. So we're going in this direction, and this should allow the default route that's being originated by the ASBR and also the access layer prefixes attached to router 7 into the EIGRP routing domain. At that point, we go under the EIGRP process, okay? And we type in the redistribute OSPF version 3.1, and please refer to the route map into EIGRP, where he will set the metric of the following and tag it with the number 44. So let's go ahead and apply this configuration, and we'll analyze the outcome of it. I'll be right back. All right, so I've just applied the configuration, so let's go take a look. So I'd like to go on to EIGRP router 3, for example, and if I do a show IP route EIGRP, you can see that the configuration is actually working properly, because the only two routes that are being advertised into the EIGRP routing domain are the default route being originated from the autonomous system border router that's connected to the internet. So you see that here, okay? And you are also seeing these prefixes. These are the subnets that are attached to the access layer of router 7 out in area 1. You can see that they're making their way through backbone area 0 into the EIGRP routing domain, and effectively finding themselves onto router 10, which is EIGRP router 3. If we go into or go on to Acme Edge 1, for example, we can do the opposite verification. So we're going to go show IP route OSPF version 3, pardon me. And look, we can definitely see that the only route, oh, hold on a second. I think I need to update this because it didn't catch it properly. There you go. Okay, so it's up there. So you can properly see that the only route that's being advertised or redistributed into the area 0 backbone from the EIGRP routing domain is effectively the access layer IP version 4 prefixes that are attached to router 10. If we do the IP version 6 equivalent, route OSPF, you can see that this is also true, right? Because the only external route that is being advertised from or redistributed from the EIGRP routing domain into backbone 0 at the IP version 6 address class level is the access layer IP version 6 prefixes that are attached to router 10. And that's fantastic. If we go on to router 7, just for our last verification, we do show IP route OSPF, you will see that the redistribution prefixes actually don't pertain to this particular router, because what's happening is that he's actually just receiving the default route. So the default route is properly being regenerated into this domain, and I think it has to do with the fact, I'm just going to verify here, show run begin router OSPF, because I have a feeling we left it off. Okay, no. Yeah, that's just the default behavior. So the LSA type 5s in this particular case are not allowed to be actually entered into the area. So what's happening is that it's only receiving the default route, which is perfectly fine. I mean, there's no problem with that, but that's we have a really good setup here right now. So to close off the playlist, let's try and do a ping, and let's just give it some time to see if, and there you go. We have, oh, there's a little bit of a problem. Oh, there you go. We have connectivity. So you can see how there's connectivity from an IP version 4 level. And if I do, let me go back to this. If I do a ping, there you go. You can see that we now have connectivity even at an IP version 6 level. So what effectively we've done, if we did a ping test from 86, went through here and hit 65. So we have and then connectivity. And that's how you manage your routing tables, your topology tables, and your OSPF database tables using redistribution, prefix lists, and in companionship to route maps. I hope you enjoyed this video series, and thank you for joining me.